Hello. So we have started interpreting scatter plots. This official standard says I can construct and interpret scatter plots. So constructing is the part we're going to focus on today, and we're also going to learn a little bit more about interpreting them. So just to be clear on that language of your standard, constructing the scatter plot means you can actually make one. Can you create one yourself? For the first video we did, they were all made and we were really just interpreting them. So you're going to learn how to make them today, which if you know how coordinate plane works and how to plot points, then you already kind of know how to make them. We're just going to make sure we include all the statistical information. Constructing is making them, and then interpreting them is once it's made, what are you looking at? To interpret it means what does the general shape of the data tell you about those two variables? So constructing them can get a little bit tedious. And if you are drawing this out on your own paper, I would say you do not necessarily need to write this entire table of data down. You'll just show it on your scatter plot. So number one says, a company that manufactures candles tests the amount of time it takes for several candles of several different weights to burn. So, if you take a candle and you light it, it's not going to burn forever. It'll eventually melt all the way down to the bottom and then stop being a candle. So, they took the weight of the candle in ounces. How much does the candle weigh? And then they just let the candle burn and measured how much time before it just burned out. And they compared those. So we have a table of information with our two variables on it. And just to make sure we're clear on this, this is just like when we're doing a table of values when we're talking about functions and everything else. This is like an X and a Y. It's two variables. So we have all of our candle weights up here in ounces, from 2 ounces all the way up to 26 ounces. And then we have along with that the amount of time it took that candle to burn. And each of these together is one candle's information. So right here, this is one candle that weighed 2 ounces and burned for 15 hours. So these are ordered pairs that go together. And I can count and I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 candles were measured here in this data. So I'm going to take all of these, which these are really just, if they're just ordered pairs, then I can put them on the coordinate plane. Now this one already has a scale drawn for you with labels, which makes things a little bit easier. Sometimes it's easier if you get to pick your own scale, but that's something we'll practice in just a second. The other thing you should always have in a good scatter plot is you should have a title. So overall, I would describe this scatter plot, it's going to represent candle burn times. So I'm giving my scatter plot a title. They have already labeled on here not only a scale for the x-axis, but they've also put a label for the x-axis. The x values, as we put in the table, are weight in ounces, so they put weight down here. They also have a title and a scale for the y-axis, burn time. Now, I'm also going to pay attention here and make sure I notice that their scale down here, because this can get a little weird, their scale goes by threes all the way up to 30. And that's because the biggest one they have is a 26, so we had to make sure we fit all that. Now that means I'm just going to kind of keep in mind that that means this is like thirds, right? So this would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. Okay, so when I have data with a 5, that's like here's 3, 4, 5. That's going to go up here. Now, these go by 20s, which means everything in between this is like 10, 20, 30, 40, 50, 60, 70, 80. There's 90, 100, 110, 130. Just to kind of give me a guide, because I can see from the values in my table, these dots are not going to go on corners, most of them, which sometimes makes it tricky, but that also just means you're just kind of eyeballing it, okay? So let's try plotting these points. So this ordered pair is 2, 15. So 2 is the weight. So I go over, here's 2. This is 10, and so 15 would be like halfway between 10 and 20, about right there. And some of these dots will get a little mushy. And I even like to cross them off in the table when I've got them on my scatter plot. Because look right here, then I'm supposed to go 2,16. Well, that's like directly above it, and already I'm kind of mushing those dots together because they're so close on my scale. 2,18, that's still like right there. So there's 3 candles worth of information all squished right in that same spot. All right, now I'm moving on to 3 ounces. 3 ounces was 20 hours. Hey, that's an actual corner. That's fun. 3 ounces was also 33. So that jumps me up. That would be 30. Here's about 33. Okay, just eyeball it the best you can. 4 ounces is 34. 4 ounces and 34, just a little bit above the last one. 4 ounces and 35. Those are going to be basically right there together. 5 ounces and 38. So 35, 38 is a little closer there. 5 ounces and 40. Oh, I went 5 ounces and 36. See how mushed some of these get? Okay, now we're jumping up to 10 ounces. So this was 9, so 10 is about right here. You guys doing okay? 10 and 40, so that's 20, 40 right there. 10 and 40. Then 10 and 80. Wow, that's, I wonder what that candle, what made that candle so different. That was 10 ounces, but burned for 80 hours. Okay, so 10, here's sometimes what I like to do just so I don't have to try and follow. When I'm eyeballing, it gets tricky. So if I find this vertical place right here, I'm gonna just go 20, 40, 60, 80. And then look, the next dot is also 1080. So that's, you can't really distinguish that. That's in the exact same spot, but just know that there's 2 pieces of data right there, even though it looks like 1 dot. Okay, now we're going up to 16, which is right here. 1695. So here I'm going to go like this. 20, 40, 60, 80. So 90 would be halfway, and 95 would be halfway again, 3/4 the way up. So see how I kind of eyeballed that to find the right place? 16, 100, 20, 40, 60, 80, 100. Here's 16, 100. 1698 is just a little bit below. Kind of looks almost like the same spot of where I just was. Now I'm going over to 22 ounces. That's right here. So 22 and 120. 2, 4, 6, 8, 10, 12. There's 120 right there. See how I found that? 22, 120, and then there's 22, 125, which is going to be about 1/4 of the way up there. 22, 175, this is 120, this is 140, this is 160, this is 170, so 175. It's about right there. And then we're over to 26. This is 25 and this is 26. See where I'm at there? 26, 174. Okay. 2, 4, 6, 8, 10, 12, 14. There's 160. There's 170. There's 174-ish. And then 26, 180 is that last one right there. Phew, we did it. We got all 21 candles on this scatter plot. You guys just constructed a scatter plot. Well, kind of. I mean, all of the scales and everything were already done for you. But you did take that data, which if it's numerical bivariate data, it's really just ordered pairs. I'm going to say that again. If it is numerical bivariate data, it's just ordered pairs. So we took those ordered pairs, we plot them on a coordinate plane, and now we're ready to do what we started doing last time, where we were looking at patterns and associations. What do we see in this table? Well, first of all, I see a very clear upward trend. Now, we're also going to pull in a word that's been a big word for our 8th grade year. We've just maybe forgotten it because we haven't said it for a long time. This overall graph, do you know what I could actually do? I could take a ruler here. Now, it is clear that these do not all line up in an exact line. It's called a scatter plot. They're kind of scattered. But if I take a ruler and I kind of draw somewhat of a line here, what I see is, no, those purple dots do not line up on an exact straight line, but they do follow a general linear pattern. So we're going to add an idea to our interpreting of scatter plots as we construct them today. We're not just going to talk about positive and negative and no association. We're still going to talk about that, but we're also going to add to it the idea of, does it follow a linear trend? Does it look linear? Remember, we learned a lot about this word linear through 8th grade. We learned, is it a function or not? And then we got more specific, if it is a function, is it actually a linear function or is it nonlinear? And we're going to apply that to scatter plots here. So this does follow a general trend of following about where that green, those purple dots about follow where that green line would go. So associations, here's what I'm going to say. There is a positive, that word is still very important. Remember, that means as one variable goes up, so does the other. I see this upward trend like a positive slope. What that means is the more the candle weighs, the longer it burns. As one goes up, so does the other one. That makes sense. The more it weighs, the more wax there is for it to burn through and makes it last longer. There is a positive, but I'm going to add a word here. Positive linear association. There is a positive linear association between, let's look at the two variables we have. There's a positive linear association between the weight of a candle. Something's being set up downstairs. There is a positive linear association between the weight of the candle and the burn time of the candle, which makes perfect sense because, and I would imagine too, that's why there's some differences, even though we have like this 10 ounce candle that burned that long and that long. I wonder if we brought in a factor of not just how much the candle weighs, but does it make a difference if you make like a tall, skinny candle? Does that burn longer versus a shorter, flatter candle with more wicks? How does that work? So maybe that accounts for some of the differences, even though it weighs the same. Maybe it's a different cylindrical shape. Wonder if any of that makes a difference. But in general, what I see, I've constructed a scatter plot here, and now I am interpreting the scatter plot here. I see a positive linear association between the weight of the candle and the burn time of the candle. Okay, now you guys are going to try constructing some more, but I'm going to help you just set up the next couple, and then I will have you pause the video and try to construct them yourselves, and then come back and take a look at my scatter plots and see if they look similar. So another scenario that's not about candles, down here, number 2. A hot cup of tea was placed on the counter. So you boiled the tea, you put the tea, you poured it, put the tea bag in there, and then you just left it on the counter. Okay, so the temperature of the tea was measured every 2 minutes from when the cup was poured. So this is all about the temperature of the tea. So actually right now, I'm going to do that thing that I know is really good to do on a scatter plot, and I'm going to give it a title. I'm going to call it tea temperature. That is what the scatter plot is going to be about. And they gave us the results in this table, and I see really clearly in this table, I see an X and a Y. The first variable they're giving me is time in minutes, and the next variable they're giving me is the temperature of the tea. So this is looking at what happens to the temperature of the tea over time as it sits on the counter. And before I construct a scatter plot, I like to do, the reason I didn't start you with constructing before and we started looking at variables and association is because most of the time you have a pretty good guess about what you think should happen. And then if you have a good guess, do you think it should be positive, negative, or no association? Then once you construct your scatter plot, you're in a much better place to make sure you didn't make any mistakes because you already kind of had an idea of what should happen. All right, so I need on this one, and this is what I'm going to help you guys set up, I need a scale. This one did not give me a scale or any labels on this. All it gave me was a grid. So when I am picking a scale, let's start on the x-axis. That goes up to 30. We've done this in class before in looking at real-life linear applications. So we do have some practice in this. But when I'm looking at a scale, I count how many spaces are given to me if I'm not making my own. And I see how far I have to go. And I do a little division to see what would be a reasonable scale to use. So if I start counting these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, there's 15 slots and I got numbers up to 30. They already even go by 2s. So it makes a lot of sense to me to let these go by 2s. So I'm going to go ahead and label this 2, 4, 6, 8. You could even skip if you wanted to and not label every single one. 16, 18, 20, 22, 24, 26, 28, and 30. So I got those labeled. And I also really need to do this. I need to tell myself that here on the x-axis, I have time in minutes. That is one variable being compared in this scatter plot. The other variable is the temperature. And I actually see already that it starts high and starts going down, which makes a lot of sense, which is going to help me describe some associations. But first, I need to figure out what a reasonable scale would be. And I already know, because I counted this one too, that it goes, this is a 15 by 15 grid. If the highest is 180, I'm going to do 180 divided by 15. And it actually gives me 12 exactly, which I don't know. These numbers are kind of all over the place, so it doesn't really seem like, I mean, 12 is okay. I'll count by 12s, I guess, and get exactly what I need. Let's test our, multiplication facts. So this is 12, 24, 36, 48, 60, I'm just adding 12, 72, 84, 96, 108, that's 12 times 9, 120, 132, 144, and even if I don't have these memorized, I just keep adding 12, 156, 168, and that takes us up to 180. And this side is the temperature of the tea in degrees Fahrenheit. Okay, now you got a scale. In just a second, you guys are actually going to go through and use your ordered pairs and plot them and see what the scatter plot looks like. Much like the one above with the candles, yeah, you'll be kind of estimating where some of these dots are. That's fine. You'll try that in just a second. First, flip over to the back side. I'm going to help you set up one more that I want you to try. So number 3 on the back talks about, mine printed an old one, so it says something weird, but yours should say the correct thing. You surveyed your friends and you asked them 2 things. You asked them, how many pets do you have? So that's one variable. You can see that in the table. And you asked them their shoe size. And this is the information you gathered. So this table goes across, but it's really no different. This is our X, number of pets, and this is our Y, shoe size. So you can see this individual here has 1 pet, and where's the shoe size? 5. So I set up for you, and I looked right here, and I went 1 through 10. That's probably going to be able to go by ones because those numbers don't get very big. And the highest on this list was the shoe size 11. So when I counted these over here, I found that everything could totally go by ones, and that was fine. So number of pets, there were 10 spots, and that was the most somebody had, 10 pets. So 1 through 10, and then I wrote number of pets here, so make sure you get that labeled. And then over here, shoe size, I really did go by ones, I just didn't mark every single one. So you can see I skipped and wrote 2, 4, 6, 8, 10, 12, but these are really going by ones. And then I put shoe size over here. So, and then I put a title up here, pets and shoe size. Now, you guys are going to pause the video here and you're going to go back and you're going to create this scatter plot, and you'll go back and create the other scatter plot. Actually, use the table, construct your scatter plots, and then we will come back and talk about any patterns or associations that you see. So pause right now, pause it, construct. Okay, ready? So this is what my scatter plot looks like when I plot the tea temperature over time. Now, first of all, this one had a very clear functional relationship because it is over time, so it seems less scattered. There is a clear pattern, but I would ask, if I was going to take a ruler and try to draw a line, does it seem like the purple dots continue following a line? And this is one of the things we talked about in class back when we talked about linear functions, is this is a curving pattern, which makes this one nonlinear. It's one of the types of relationships you're going to learn about in 9th grade. But all you need to know, again, for now, is that this is considered nonlinear. Now, does it still have a clear downward pattern? Yes, it does, which makes sense because as one variable increases, time, what's happening to the other variable? Temperature decreases. So this is still a negative association. It's just not a linear one. So as time goes up, temperature gets cooler. As the tea sits on the counter, it cools down. Now that will eventually level off. It even is already starting to, which tells me that's probably about room temperature, 70-something degrees. So it can only cool down as cool as the room is, unless you put it in the fridge. But so our associations here This is a negative nonlinear association. You could also have a positive nonlinear association, but this is our new idea here. So it's still a negative association because as one goes up, the other goes down. Anytime the variables clearly move in opposite directions, it's a negative association, but this one is nonlinear. There is a negative nonlinear association between the time and the temperature of the tea. Make sense? All right, let's see how we did on the pets and the shoe sizes. Now, did you have a guess as you went? Did you kind of even go, why is somebody asking this and putting it together? Well, you probably had a guess, and hopefully your scatter plot supported that. So as I plotted things, this is where my purple dots ended up. And I do not see a clear increasing or decreasing pattern. And when there's not even a clear association, then there certainly is not going to be a linear or nonlinear pattern if there's no association at all. So you really only have to worry about linear or nonlinear if there's a positive or negative association. This one is simply no association between the number of pets and your shoe size. There's nothing like the bigger your shoe size, the more pets you have, or the bigger your shoe size, the less pets you have. There's nothing like that. It's just all over the place. So when there is no association, you're not going to have to worry about linear or nonlinear. Now, the last four of these didn't ask you to construct anymore. It's just practicing this new idea, adding on the linear and nonlinear in our interpretation. But remember, this entire standard is I can construct and interpret. So as you go to your next MLE, it's actually on Elluminate because it's practicing this, but it's also an overall practice test for this standard. So you'll have an MLE in Elluminate. Email me if you have any questions about things you missed on there because I can't type in comments in Elluminate like that. So email me if you're like, I missed question 4 and I don't know why. I'll explain it to you and make sure you ask me before you do the next thing because the test is also in Elluminate. So you have a practice test in Elluminate, which is just an MLE, and then your actual test in Elluminate. But it's all this standard. Can you construct them? And can you interpret them? So let's practice just a few more. If you look at number 4, I hope you see a clear positive pattern. Number 5, I see a clear negative pattern. Now we're just gonna add to that the fact that is it linear or not? So on number 4, and again, it's obviously not an entire straight line, but does it seem to continually follow where a line would go? And if the dots are still continually following about where a line would go, then we consider it a linear association. So this is positive and linear. This one, if I draw a straight line, I've got all these pieces that did not follow that straight line. Again, this is a curvy one. So this is negative again, but it's nonlinear. And just because we've had 2 examples of negative nonlinear, you could totally have a positive one. It would look something like this, or maybe it would even look like this. You could definitely have a positive association that's nonlinear. Okay, now check out 6 and 7, the last couple here. Number 6, I cannot say positive or negative because it starts going up and then it turns and comes back down. This is actually a name and a relationship you'll learn about in 10th grade. So all I can really say here is that this one is clearly nonlinear. There is a pattern here, but it's positive and then it switches to negative. So I can't really say one or the other, but it is nonlinear. It's nonlinear. And this one, I know it's pretty spread out here, but in general, if I drew a line coming down here, in general, those dots are not curving, they're still following that linear path. So this is negative and it's considered linear.